You're floating in open water. No land in sight. No boats. Boats won't exist for another 460 million years. The water is warm, warmer than any modern ocean, and it stretches in every direction as far as you can see. You look down. The surface light fades fast, maybe 30 feet of visibility. Below that, nothing. Just a deep blue-green darkness that goes down and doesn't end. There are no fish here, not one. There are no sharks, no whales, no dolphins, no rays. Nothing with a backbone bigger than your thumb exists anywhere on this planet. And that should make you feel safe. It shouldn't. Because this is the Ordovician Ocean, roughly 470 million years ago. And it is, by almost every measure, the deadliest body of water that has ever existed on Earth. Not because of what it has that you recognize, but because of what it has that you don't. This ocean is run by creatures that have no spine, no bones, and no mercy. Armored invertebrates the size of cars, sea scorpions with claws built like serrated knives, and one apex predator, a thing with tentacles and a shell that grew longer than a school bus. This is a world before fish, before jaws, before vertebrates figured out how to fight back. And right now, you're treading water in the middle of it. Let's go down. The first thing you notice on the seafloor is that it's alive. Not in the way a modern coral reef is alive. Bright, colorful, chaotic. This is different. The bottom is covered in a dense, gray-brown carpet of shells, segments, and slow movement. Thousands of them. Tens of thousands. Trilobites. They're everywhere. Crawling across the sediment, burrowing into it, sitting motionless in clusters like armored beetles, waiting for something to walk by. Some are tiny, the size of a coin. Others are the size of a dinner plate. A few, in the deeper water, are pushing 70 centimeters, about 2.5 feet, which makes them roughly the size of a large dog. A flat, armored, many-legged dog with no face you'd recognize. Trilobites had been around for over 50 million years by this point. They were one of the most successful animal groups in Earth's history. Over 20,000 species. They filled every niche: predator, scavenger, filter feeder, parasite. Some had spines, some had horns, some rolled into balls like armored pillbugs. But here's the detail that gets genuinely unsettling. Their eyes. Trilobite eyes were made of calcite, a mineral. Not protein, not soft tissue. Actual crystal. Each eye contained hundreds of individual lenses, arranged in a honeycomb grid, giving them nearly 360-degree vision. Some species had eyes on stalks. Some had bifocal lenses, 2 focal points per lens, which is an optical trick that humans didn't figure out until the 18th century. These animals solved compound optics 470 million years ago. With rock. So yeah, the floor is covered in thousands of crystal-eyed, armored invertebrates that have been perfecting survival for 50 million years. That's the easy part. Now look up, away from the bottom, into the open water. Something moves. It's fast, faster than anything on the sea floor. A long, conical shell, maybe half a meter long, jet propelling itself through the water with short bursts, tentacles trailing behind, 2 large eyes scanning the water ahead. This is a nautiloid, not the slow, drifting nautilus you might have seen in an aquarium. This is its Ordovician ancestor, smaller, quicker, and actively hunting. These were among the first truly mobile predators in the open ocean. While trilobites crawled and grazed, nautiloids moved. They used jet propulsion, sucking water into their shell cavity and blasting it out, to chase prey, change direction, and strike. And there were a lot of them. The Ordovician Ocean had dozens of nautiloid species, ranging from a few centimeters to over a meter in shell length. They filled the mid-water column the way fish fill it today, except they'd been doing it for millions of years before fish even evolved jaws. Think about that for a second. The entire mid-water predator niche, everything that sharks, tuna, barracuda, and swordfish do today, was occupied by shelled cephalopods. Jet-powered, tentacled, shell-wearing cephalopods. No bones, no fins, no vertebrae, just muscle, shell, and a surprisingly complex brain. And these mid-sized nautiloids? They were the middle of the food chain, which means something was eating them. The shadow passes over you before you see it. Long, low, moving with a slow, deliberate rhythm. Not jet-propelled like the nautiloids, but swimming. Legs, lots of legs, and at the front, two appendages that don't look like anything you want to be near. This is Megalograptus, a eurypterid, a sea scorpion, about 1.2 meters long, roughly 4 feet, which doesn't sound enormous until you remember that this is an arthropod, an invertebrate. In the modern ocean, the largest arthropod is the Japanese spider crab, and it's mostly leg. Megalograptus was mostly weapon. Its front appendages were covered in long, forward-facing spines, not claws that pinch, but raking tools designed to sweep through the water and impale anything soft-bodied. Imagine 2 arms made of serrated combs, each spine as long as a human finger, all pointing forward. It didn't chase. It ambushed. Sitting motionless on the seafloor, blending into the sediment, waiting for a trilobite or small nautiloid to drift too close. Then, a strike, fast enough that the prey likely never saw it. And Megalograptus wasn't even the largest eurypterid of the period. Its relatives would eventually grow to over 2.5 meters, 8 feet, making them the largest arthropods that ever lived. Sea scorpions the length of a human lying down, with crushing claws and compound eyes that could track movement in murky water. For roughly 50 million years, eurypterids were among the most effective predators on the planet. They dominated shallow coastal waters, estuaries, and even some freshwater environments. But here's the thing nobody talks about. They weren't the top, not even close. You feel it before you see it. A pressure change in the water, a low vibration, something large displacing a lot of water, moving slowly, somewhere in the blue haze ahead of you. And then it appears. A shell, straight, not coiled, like a battering ram pointed forward. Dark brown, ridged, tapering to a point at the back. And it just keeps going. 1 meter, 2 meters, 3, 5. Endoceras, the largest cephalopod, and quite possibly the largest predator, of the entire Ordovician period. Estimates vary, but the largest Endoceras specimens reach somewhere between 6 and 9 meters in length, roughly 20 to 30 feet. That's the length of a school bus, a straight-shelled cephalopod the length of a school bus. For reference, the largest modern giant squid ever measured was about 13 meters, but most of that was tentacle. Endoceras was almost entirely shell and muscle. Dense, heavy, solid. At the front, a cluster of thick, muscular tentacles, probably 8 to 10 of them, each capable of gripping and pulling prey toward a large, sharp beak. A beak strong enough to crack through trilobite armor, strong enough to crush a sea scorpion's exoskeleton. And it had eyes. Large, forward-facing eyes with good depth perception. A predator's eyes. Now picture this animal in its world. The largest fish on the planet at this time was maybe 15 centimeters long. Jawless, spineless, defenseless. The largest sea scorpion was about 1.2 meters. The largest trilobite, maybe 70 centimeters. And here's Endoceras, 9 meters, in a world where nothing else breaks one. This is what happens when an ecosystem has no vertebrate competition, when there are no sharks, no marine reptiles, no whales to fill the apex role. Invertebrates fill it instead, and they fill it with something that looks like it belongs in a science fiction movie. Endoceras cruised the Ordovician Ocean for millions of years, with essentially nothing capable of threatening it. No predator, no rival, no challenge. It was, in every meaningful sense, the first true apex predator the ocean ever produced. And for a while, that was enough. Now, in the middle of all this, there's one more thing in this ocean you should know about. Hiding in the shallows, hugging the coastline, darting between rocks and trying very hard not to be noticed. Arandaspis, one of the first fish, about 15 centimeters long, roughly 6 inches. No jaws, no teeth, no fins worth mentioning. Just a small, armored head shield and a soft, wriggling body that could barely swim in a straight line. This is your ancestor. Every shark, every whale, every eagle, every human, every vertebrate alive today traces its lineage back to something that looked a lot like this. A 6-inch, jawless, defenseless lump hiding from sea scorpions in the Ordovician shallows. It's almost funny. In an ocean ruled by 9-meter cephalopods and armored scorpions, the future belonged to this, the most unimpressive animal in the entire ecosystem. But it had one thing nothing else did: a spine. And in about 50 million years, that spine would change everything. But not yet. Not here. Here, Arandaspis was nobody. Prey. A footnote in an ocean that didn't care about it. There's something almost poetic about that. Roughly 445 million years ago, the Ordovician Ocean began to die. It didn't happen all at once. It started slowly, a cooling trend that had been building for millions of years. Global temperatures dropped. Ice sheets formed over what is now the Sahara, which at the time sat near the South Pole. The ice grew and grew and kept growing until it covered most of the southern supercontinent of Gondwana in a sheet of ice kilometers thick. Sea levels plummeted. The warm, shallow seas that had covered most of the world's continents, the seas where trilobites thrived, where nautiloids hunted, where Endoceras ruled, those seas drained. Hundreds of thousands of square kilometers of habitat. Gone. Not destroyed. Just emptied. The water pulled back and didn't come back. The reefs collapsed first, then the filter feeders, then the grazers, then the predators. 85% of all marine species on Earth went extinct. 85%. The trilobites survived. Barely. They would never again be the dominant group they were. The nautiloids survived, but most lineages vanished. Endoceras and its giant relatives, gone. Completely. The largest predators the Ordovician Ocean ever produced didn't make it through. It was the first of Earth's 5 great mass extinctions, and while it wasn't the largest, that title belongs to the Permian, 200 million years later, it was, in many ways, the cruelest. Because this ocean had been stable for nearly 50 million years, life had settled in. Ecosystems were complex, interconnected, balanced, and then the temperature dropped, the water vanished, and none of it mattered. 50 million years of evolution, erased in maybe a million. That's the thing about deep time. It gives, and it takes, on a scale that's hard to even hold in your head. But here's what I keep coming back to. In the middle of that extinction, while the reefs died and the giant cephalopods vanished and 85% of species disappeared, something survived. That small, jawless 15-centimeter fish hiding in the shallows, It made it through. Barely. But it made it. And over the next 100 million years, its descendants would evolve jaws, teeth, bones, and muscle. They would grow. They would become the sharks, the armored fish, the monsters of the Devonian. They would take the crown that Endoceras left behind. The Ordovician Ocean died. But the line that started here, the vertebrate line, your line, that survived, and what came next, was somehow even stranger. In the next video, we're looking at a single fossil, one creature, that paleontologists have been arguing about for 60 years. They still can't agree on what it is, not what it ate, not how it lived, what it fundamentally is, animal, plant, or something else entirely. Until next time, stay curious, stay terrified,